Alright guys, this is Unit 5, Lesson 7, Interquartile Range. A quick review, the 5-number summary includes the minimum value, the first quartile, the median, the third quartile, and the maximum value. The first quartile, or Q1, is the value that is 1/4 or 25% of the way through the data set. 25% of the data will fall below the first quartile. It's calculated by finding the median of the lower half of the data set. The median is the value that is halfway or 50% of the way through the data set. It's also the second quartile, and it means that 50% of the data will fall below the median. To find the median, it's really easy. You just find the center number. There's no math involved. The third quartile, or Q3, is the value that is 3/4 of 70 or 75% of the way through the data set. 75% of the data will fall below the third quartile. It's calculated by finding the median of the upper half of the data set. Interquartile range, or IQR, measures the spread of the middle 50% of the data, and it's calculated by subtracting the first quartile, Q1, from the third quartile, Q3. This little formula right here should be in your notes. We're going to be finding the interquartile range a lot today. Here's example number 1. Help Ethan summarize his data set of how many seconds the daycare dogs were able to resist eating the whipped cream after he left the room by calculating the 5-number summary and the interquartile range. And then it gives us a data set. So the first thing you always need to do with a data set like this is put it in ascending order. So it needs to go like 2, 3, 4, okay? And that's what, oh, there's a 1 in there. See, I missed 1. So that's what they did here, okay? Now you need to find each of the 5 numbers, starting by identifying the minimum and the maximum values. These are super simple, which I always appreciate. Easy math is the best for me because I am not a math person, okay? The minimum number is going to be 1, and the maximum number is going to be 30, okay? So we see the minimum is 1, the maximum is 30. Next, you're going to calculate the median, which is the center value. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 values, so 20 divided by 2 is going to give us 10, okay? Now remember, when you have an even number, you need to take this value and the next one. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 11 and 13. If you add those together and divide by 2, the value in between that is the median. So in this case, the median is going to be 12, okay? So we have a minimum of 1, a maximum of 30, and a median of 12. This means that 50% or 2/4 of the data is below 12. Next, calculate the first quartile. So we're going to find the median of the lower half of the data set. So right here is where this data set is going to divide. We're dealing with only here, and we're going to find the median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. 10 divided by 2 is 5, so we need 1, 2, 3, 4, 5. We need 5 and the next number because it's an even number, an even set. So the number between 4 and 6 is going to be 5, which means quartile 1 is going to be 5. Okay? The first quartile is 5. This means that 25% or 1/4 of the data is below 5. Now we need to calculate the third quartile, so we find the median of the upper half of the data set. So 1, 2, 3, 4, 5, 6. Oh, I already know that the median's 12. Duh. 1, 2, 3, 4, 5. So we need this one and this one. And we need to find the number that's in between those two. So 22 plus 28 is going to give us 50, right? 50 divided by 2 is going to give us 25. So quartile 3 is equal to 25, okay? This means that 75% or 3/4 of the data is below the number 25. The 5-number summary for the whipped cream resistance data is 1, 5, 12, 25, and 30. Now we need to calculate the interquartile range by subtracting the first quartile, which is 5, from the third quartile, which is 25. So all we do is we do 25 minus 5 is equal to 20. So our interquartile range is 20. I've got to slide to get to the next slide. Okay, so the interquartile range is 20. This means that the middle 50% of dogs had a spread of 20 seconds. So half of the dogs ate the whipped cream within a 20-second spread of the data, okay, within a 20-second time period. The 5-number summary condenses the data set into 5 key numbers. The interquartile range describes the spread of the middle half of the data set. This is all we're doing this whole lesson, okay? So let's keep moving. We're going to talk about a skewed data set. A skewed data set is one that is not symmetrical. The mean and the median will not be the same. Many skewed data sets have one or more outliers or values that fall outside the typical values of the data set. So how do we determine outliers? Using the interquartile range. So there's 2 formulas that you need for this to find what they call fences. Okay, we're going to go back to our box and whisker plots, which looks something like this. You may remember this from an earlier lesson. Okay, so the fences are this line right here. This is the lower fence, and this line right here, which is the upper fence. Okay, and what these fences tell us is that any number down here is an outlier and any number up here is an outlier, which means that it doesn't fit the rest of the data. Most of the data fall in here, and so if you have something out here, like if you have one dog that never ate the whipped cream, that's really unusual. Maybe the dog is blind or dead. I don't know. Okay, so that would be an outlier. It would be clear over here, right? Or if you have dogs that immediately eat the whipped cream because they have no training like mine and they don't care what you say, that might be an outlier if you only have 1 or 2 dogs that do that, but the rest all behaved, okay? So you need these 2 formulas in your notes so that you can figure out outliers. This is only a small part of the lesson, but you do need the formulas in your notes. So here's example number 2. Calculate the 5-number summary and the interquartile range of Gregor's data set. Then use the interquartile range to help identify any outliers in his data set. So there's 3 things we need to do here. We need to get the 5-number summary, we need to get the IQR, and then we need to identify outliers. Okay, so the first thing we need to do is check that this is in ascending order. It looks like it is, so we don't need to do any rearranging there. So first we need to do the 5-number summary. The minimum is going to be 0, and the maximum is going to be 670. Okay, the next is to find the median. And in order to do that, we need to find the center number. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's an even data set, so we need both numbers. So 59 plus 68, calculator time. 59 plus 68 gives us 127 divided by 2 gives us 63.5. So our median is going to be 63.5. Okay, now what we need to do is find quartile 1 and quartile 3. So these are going to divide right here. Okay, so 10 data points. We're going to go 1, 2, 3, 4, 5. We need 30 and 38. Now I'm guessing it's going to be 34, but I don't trust myself. So we're going to go 30 plus 38 gives us 68 divided by 2 gives us 34. So Q1 is going to be 34. Now let's solve for quartile 3. 1, 2, 3, 4, 5. We have 80 and 90. In between those two is going to be 85. So there's our 5-number summary. Okay, if you're struggling with this, go back to the lesson about 5-number summaries or leave a comment and I will go through this more slowly. I'll make another video. Okay, so our interquartile range is 0, 34, 63.5, 85, 670. I did it right. Yay, me. Now we need to find the interquartile range of the data set. You do that by taking quartile 3, which is 85, and subtracting quartile 1, which is 34. And that's going to give us 151. Okay, that's our, and now we need to do math to figure out the lower fence. So the formula for the lower fence is quartile 1 minus 1.5 times IQR. So quartile 1 is 34 minus 1.5 times our IQR. Oh, we need to figure out the IQR. IQR is quartile 3 minus quartile 1. Calculator, because I don't want to try. So 85 minus 34. Our IQR is 51. Okay. So now we need to follow PEMDAS. So 51 times a negative 1.5. Calculator, 51 times 1.5 is going to give us a negative 76.5. So 34 minus 76.5. Do you love how clearly I'm writing this for you? Oops, nope, come back, calculator. 34 minus 76.5 gives us negative 42.5. Okay, so the lower fence is negative 42.5. Okay, and this is the lower fence. Okay. Oh, guys, I figured it out. I had this wrong clear back here. For quartile 3, it's plus, not subtract. So I apologize. Go fix that in your notes. Oh my goodness. And then if you do that right, you can come back over here to what we've been doing. And if you add these two numbers instead of subtracting, then it all makes sense. Because 85 plus 76.5, 85 plus 76.5 gives us a bigger number, which is going to be 161.5. Okay, and that means that there's two outliers here, these two at the end, which makes sense because if you look at this spread of data, these ones seem really, really, really big compared to all of the other numbers, especially 670, right? Okay, so that's the problem. The interquartile range for quartile 3 is add, not subtract. I apologize. I apologize. I apologize. Okay, so we got this figured out. The upper fence is 161.5. Okay. So now let's do a quick review on box plots. They're also called a box and whisker plot. They're a visual representation or model of the 5-number summary. They can be constructed horizontally or vertically, and data can be symmetrical or skewed. This one is symmetrical. The lines right in the middle of the box and the whiskers are the same length, so that's symmetrical. If either of these things is off, if the line's clear up here or if one whisker's long and the other's short, then it's not symmetrical, it's skewed. Okay? Data is symmetrical when the ends of the box, these whiskers, are equidistant from the median line inside the box. Oh, it's talking about this. This line in the middle is in the middle. Or when the whiskers are the same length. And when the whiskers, it has to have both that. This line has to be in the middle. These have to be the same length. If there's a small number of outliers, the box plot may be modified to indicate the outliers separately. Outliers will be plotted individually as open dots, X's, or asterisks. So if this had one outlier that was clear up here, they would just draw it as an X right here to show that there was an outlier and not let it screw up the rest of this. Okay. Here's a check-in. How can the median and the first and third quartiles help determine if a data set is skewed or symmetrical? What else must be considered? This goes back to the box plot. The median would be right here, and the first quartile and the third quartile would be here. So you can determine if it's skewed or if it's symmetrical because of where this line is in the box. If the line is in the middle, then the data set might be symmetrical. You still need to see the whiskers, okay? If the line in the box is closer to one end than the other, then it's skewed. You know automatically it's skewed. You don't have to see the whiskers to know that, okay? Here's example number 3. Use the 5-number summary to construct a box plot for Griffor's data set of salaries. Identify outliers with X's, okay? So first we need to find a 5-number summary, and then we need to make a box plot, and then we need to identify outliers, okay? So let's start with the 5-number summary. Our minimum is 0. Our maximum is 670. Okay. Is this the same data we had before? I believe it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, it is. So we already have a 5-number summary for this. I just need to go back and get it. 0, 34, 63.5. 0, 34, 63.5. 34, 63.5. And this one was 85. I remember that. Okay, so here's our 5-number summary. Okay, if we're going to make a box plot, we're going to have our median right here. Here's our number line. Down here is going to be 63.5. Okay, and then we're going to have 34 over here somewhere. 34. And 85 up here somewhere. 85. Okay, so this is our little box chink. I'm trying to not draw it messy. This is going to come down to 0. That's our minimum. And this is going to come way over here up to 670. Okay, there's our box plot. Chink. Beautiful. Okay, now we need to identify the outliers. And we already know that these two were the outliers because we've solved this problem. So there's going to be an outlier. We're supposed to mark them with an X. So there's an outlier up here at 670. And there's an outlier over here somewhere at 231. Okay, so that's basically what your box plot is going to look like. Here is all of the steps that I just took. You can pause it and read this if there was anything that was confusing to you. Okay. Did I stop it at 105? No. Okay, so these boundaries, I did that part wrong. These are, they want the fences here. They don't want just Q1 and Q3. They actually went for the fences. And now the boxes are there. Let's look at their drawing. They didn't label everything. This is what it's supposed to look like. So I'm not sure where they drew these lines, but keep in mind that some constructed box plots will not identify outliers. It could be that the data set didn't have outliers, or the data set might be really big and has a lot of outliers. You don't want like X, 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 X. In this case, identifying the outliers is not feasible or helpful if there's a whole bunch. But for this one, there was 2, so they were like chink, chink. Okay, this is what a computer-generated box plot looks like. This is what a Bawb box plot looks like. Here's example number 4. Consider the following data set. The first thing it wants us to do is calculate the 5-number summary. So there's a note. In general, the first quartile is the median of the lower half of the data set. When a data set has an odd number of values, the first quartile is the median of the values below the median of the data set. So I'll show you what that means. First of all, you can look here and see these are not in ascending order because they suck and they want to test us. So we have to put them in order. -15 looks like the lowest. Go away. And then, nope, -80 is. -80. Okay, fine. You won. You're a superhero. Look at you. 12 next? Sure. We'll say 12. Nope. 10 was next. 10. 12. Isn't this fun? 15. 24. 24. Such a waste of time. 27. 27. 28. 27, 28. 29. 31. 31. Okay. 32. And 100. That should be everything. Let's double check I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yay! Okay, so let's find our 5-number summary. Our minimum is going to be -80. Our maximum is going to be 100. Our median, oh, I don't remember how many I counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So half of 13 is 6.5. 1, 2, 3, 4, 5, 6.5. This is going to be our median right here is 27. Okay, so if this is our median, what that does to us is we have 1, 2, 3, 4, 5 below the median. We're just ignoring the median. We're not including it in either of these calculations. So we have 1, 2, 3, 4, 5. Oh, we actually have 6 because this is over here. So we need the middle two, which is 10 and 12. So quartile 1 is going to be 11. 1, 2, 3, 4, 5, 6. So we need 1, 2, 3, 31 and 31. So they're both 31. There is our 5 number. Whatever. Systematic check of quantum analysis. Yeah. So we have negative 80, 11, 27, 31, and 100. Perfect. Now we need to calculate the interquartile range. That's Q3, which is 31, minus Q1, which is 11, which gives us 20. So our IQR is 20. Okay. Now we need to identify any outliers. And in order to do that, we find the fences. Okay. So fence is quartile 1, which I need to come back and find. I didn't add it. I'm sorry. Quartile 1 is 11. So we have 11 minus 1.5 times our IQR, which is 20, times 20. Okay, and for the upper fence, we have quartile 3, which is 31. 31 plus 1.5 times 20. Okay, let's grab our calculator. 1.5 times 20 gives us 30. So 11 minus 30 will give us a bottom fence of negative 19. Anything under that is an outlier. And then we have, I keep double clicking and closing that calculator. We have 31 plus 19. Well, I don't know. I don't remember what 1.5 times 20 is. I am so tired. 1.5 times 20, 30. Plus 31 is going to give us 61. So there's our cutoffs, negative 19 and 61. Now I need to go back to my in order stuff. So negative 19, so negative 80 is an outlier. Negative 80 is an outlier. And then our upper fence is 61. 61, so 100 is an outlier. Negative 80 and 100 are both outliers. Okay. We identified the outliers. Negative 19 and 61. Okay, we got that. Outliers are negative 80 and 100. I'm surprised I'm doing this right. Construct a box plot identifying the outliers with X's. Okay, so our minimum is going to be, here's our number line. Here's negative 80. Okay, and then we do, it didn't really clarify for me if the box should be 11, 27, immediately is 31, and then clear over here is 100. Okay, so the box should look something like this. It's obviously skewed, comes clear down to negative 80 and clear up to 100. Okay, beautiful. You can see theirs is, oh, I didn't do my X's, I apologize. You can see theirs is skewed. We had to mark our outliers. So I'm sorry, it doesn't come all the way to 80. These lines go to our fences. The fences are the end points. I'm getting it now. I'm getting it now. I'm getting it now. And the fences are at, come back, negative 19 and 61. I can do this. This is negative 19 and this is 61. Okay, this makes more sense. This shouldn't be here and this shouldn't be here. Okay, there's an outlier here and there's an outlier here. Here's a pretty one that makes more sense. Use the box plot to determine if the data set is symmetrical or skewed. It's very obviously skewed in both ways. The line is not in the center of the box and the whiskers don't match. Okay, beautiful. Okay, this is a like an interactive question, like a drag and sort thing. So here's the definitions, here's the words. Let's put them all together. A 5-number summary is a list of 5 calculations. Hey, look at that, 5, 5. See how smart I am? Including the minimum, maximum, median, first quartile, and third quartile. So that one's good. Come on, other thing. The first quartile is 1/4 of the way through. Chink. The median is the measure of center. The third quartile, 3/4 of the way through. I need all this other garbage. Come here, you. Come here, you. The interquartile range is difference between first quartile and third quartile, and outliers are markedly different from the values in the other sets of the sample. If you need to pause this and go over it, you rock on, you do that. A volleyball, this is another like interactive one, but we're just gonna write with my little pen thing. A volleyball team logged the number of spikes each player had during a tournament. Here's the thing, and of course it's not in order because they just want to make my life hard for no reason. They want us to find the 5-number summary. So first we have 1, and then 4. Goodbye, goodbye. Then we have 9, 10, 11. We're rewatching Stranger Things, so 11 made me happy. 14. 6. Nope. We need a 13. We need a 13. Emergency, emergency. We need a 13. 14. There's a 14. There's a 13. We need a 16. We need a 19. I'm out of room. We need a 20. And we need a 21. I think that's everything. Oh, nope. There's a 23. I think that's everything. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. I did it wrong. We've got the 10, we've got the 21, we've got the 14, we've got the 19, we've got the 4, we've got the 23, we've got the 9, we've got the 13, we've got the 20, we've got the 11, we've got the 16, we've got the 1, we've got the 20. Oh, I don't have 24. There we go. Now we're right. Okay, the minimum is 1. The maximum is 24. Quartile. Oh, we need the median now. I totally just counted this and I don't remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 6.5. 1, 2, 3, 4, 5, 6.5 is going to give us 14. So quartile 2 is also the median, and that's going to be 14. Okay, so we have an odd number, so we just leave this one out. 1, 2, 3, 4, 5, 6, which means we need 3 and 4. So quartile 1 is 9.5. And then 1, 2, 3, 4, 5, 6. So in between 20 and 21 is going to be 20.5. There we go. All done. All done. Fantastical magic. Okay. Seriously. Seriously, Canva. Seriously. Let's hurry and continue before it disappears. Identify the box plot for the data using the 5-number summary. And look, once again, it's not in order. I mean, like, I swear, seriously. If you've made it to the point that you're in algebra, you should be able to put these in order, and they should trust us that we can put it in order without making us do it. It's like the stupidest thing ever. 1, 4. Now, granted, I would probably screw it up because that's the way I am, but I have the capability to do it. It's just that I don't care. And I'm sure you don't care. But they want us to waste our time doing this anyway. 10, 11. 13. 14. 16. At least I remembered to not write it on the side so I won't run out of room this time. 19. 20. 21. 24. Let's make sure I've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 24. We have... Okay, I gotta start at the beginning. We have 10. We have 21. We have 14. We have 19. Yes. We have 4. We have 23. No, we don't. Okay. Okay. Go away. You're going to be 23. And then we're going to have 24. Okay. So the minimum and maximum have to be 1 and 24. This one's out. Go away. This one's out. This one's in. This one's in. Okay. The median has to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 6.5. 1, 2, 3, 4, 5. Oh my gosh. 1, 2, 3, 4, 5, 6. I can do this. I swear I can. So the median should be at 16. Okay, I did it wrong. Apparently I can't. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6. Oh, it's 14. The line has to be at 14. So this is the correct one right here. Okay, we don't have to go any further. Question number 1. This is all you. Consider the following data set representing the number of times a randomly selected group of 13 people had pizza last year. And it gives us our data. Guess what? Not in order. Calculate the 5-number summary of the data set, then calculate the interquartile range of the data set. First, put these in order. Second, find the 5-number summary. Then calculate the interquartile range. Pause it. Go do it. Come back. Don't be lazy. Actually do it. Okay, the 5-number summary is 0, 40, 60, 65.5, and 69. The interquartile range is either 25 or 25.5 because the answer is vague and stupid in the book. It gives both options. It would be 25.5 because it's 65.5 minus 40. So I don't know why they put 25 at any point. If you need help with this, again, comment. I will help you. But I feel like we've gone over this enough. You should have a pretty good grasp. Question number 2, consider the following data set representing the number of times a randomly selected group of 13 people had pizza last year. Here it is, not in order. Describe whether the data set is symmetrical or skewed. Note, this is the same data set as the last problem. Okay, so you already have all of this information. Okay, so looking at this, going from this information, you need to find out, is it symmetrical or is it skewed? Pause it, figure it out, come back. Okay. Compare the location of the median, which is 60, to the first quartile, which is 40, and to the third quartile, 65.5. This is figuring out what this box looks like, okay? So we have 40 here. We have 65.5 here. And we have 60 here. The line is going to be clear over here. So is it symmetrical or is it skewed? It's skewed. The median is much closer to the third quartile than the first quartile, okay? And it shows you doing it with math, okay? And the stupid math book literally gave this problem twice and expected that to make sense. There's huge typos in this chapter. It's a hot mess. This data set's skewed, okay? Here's question 3. Consider the following data set representing a number of times some randomly selected group of 13 people had pizza last year. Identify any outliers in the data set, then construct a box plot for the data set identifying the outliers with X's. This is the same data set as the last problem. So we have this. They want to know if there's any outliers. So pause it, figure it out, come back. Okay, to find the outliers, you need to find the fences, okay? And the fences use the math, so it's quartile 1, which is 40, minus 1.5 times our interquartile range, which is quartile 3 minus quartile 1, so it's 25.5, okay? And then you do the same for quartile 3, except it's add. Okay? Those are your fences. And then you can figure out if there's any outliers based on that. Does that make sense? I hope that makes sense. Okay. There is an outlier. There's one right here at 0 because the lower fence is at 1.75 and the upper fence is at 103.75, which is not what this shows. So I wonder where these are drawing. This one is drawn at about 25, which should be, it's probably here at this 24. Let me come back here. Let me come back and look at our 5-number summary. Where are you, 5-number summary? Beautiful, beautiful 5-number summary. It's at 40. And that is definitely not at 40. That's at 40. And our lowest number is 0, which we determined was an outlier. Oh, so the next highest number is 24, so they drew that at 24. So you mark your outlier, go to the next number in your list, and draw it there. Stop it there. And then our highest number in this whole set is 67, which they drew right there. Starting to understand. It's kind of irrelevant because you'll never be asked to draw anything in an online class, but whatever. Practice question number 1. This is at the end of your lesson, so just write your save it for later. Calculate the interquartile range of the skewed data set. And look, they finally gave it to us in order. So in order to do this, we need to start with our 5-number set. Pause it, figure it out, come back. Okay, so our minimum is 0, our maximum is 10, our median is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7. Our median is going to be 8. Okay, so now we need to figure out what it is between these two. This is our split point. So 1, 2, 3, 4, 5, 6, 7. So that's 3.5. 1, 2, 3. Okay. Our split point here is 7. 1, 2, 3, 4, 5, 6, 7. 3.5. 1, 2, 3.5. Our split point right there is going to be 8. This is an interesting 5-number. Okay. The interquartile range is 8 minus 7, which is going to give us 1. Here's practice question number 2. Calculate the values for the 5-number summary of the skewed data set. Blah. Just wants the 5-number summary. Pause it, figure it out, come back. It's already in order, finally. Minimum is 11. Maximum is 25. Median is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Half of 11 is 5.5. 1, 2, 3, 4, 5.5 is going to give us this for our median, which is 13. This is our dividing point, okay? And so this one gets left out of figuring everything. 1, 2, 3, 4, 5. So it's 2.5. So it's 12 for quartile 1. 2.5 is 15 for quartile 3. There's your 5-number summary. Here is practice question number 3. Determine if there are any outliers in the skewed data set. Enter the number of the correct option. So first, is it the same as before? 13, 13, 13, 14, 14, 15. Yes, it's the same as before. So let's just transfer our numbers over. 11, 12, 13, 15, 25. 11, 12, 13, 15, 25. Okay, they want to know, are there any outliers? Pause it, figure it out, come back. Okay, so in order to find out if there's outliers, we need to find the lower fence and the upper fence. Okay, so lower fence is quartile 1, which is 12, minus 1.5 times our interquartile range, which is 15, minus 12, which is 3. Okay. Upper fence is quartile 3, which is 15, plus 1.5 times our interquartile range, which is 3. Let's grab our calculator and solve this. 1.5 times 3, I should be able to do this, but I don't care, is 4.5. So 12 minus 4.5 gives us 7.5 for our low range. And then we have 15 plus 4.5 is going to give us 19.5. 7.5 for our upper range. So 7.5 on our lower range, there's no outliers there, and then 19.5 on the upper range, there's one outlier, it's right here, and it's 25. So this is the correct one. Remember, they shuffle these answers, so don't just pick number 2. Actually look and see which one's right on yours. Here's quick check question number 1. I won't give you these answers because you get graded on this, but I will tell you the steps to take to figure it out. Calculate the 5-number summary of the skewed data set when constructing the box plot on a number line, which explains a reason why the data set is skewed. Okay, so first find the 5-number summary. Then you're going to go ahead and create your little box plot, and it's going to be skewed. It tells us point blank it's going to be skewed. Okay, it's going to be screwed up somehow, and you're going to tell us why it's skewed. Okay, so the right whisker might be longer than the left whisker. The whiskers are the exact same length. The median is exactly in the middle of the box, or the 5 numbers of the summary are equally spread apart. Okay, I believe in you. You know what skewed means. I'll give you a hint. This one is not skewed. Okay. Here's quick check question number 2. Calculate the 5-number summary of the skewed data set. Which of the following choices is quartile 3? Okay. You should be able to do this. So you have number here, number here, number here. This one right here is quartile 3. Okay. You can do this. I believe in you. Here's quick check question number 3. Which option is true about the outliers of the skewed data set? So first you need to find your 5-number summary, and then you need to figure out what the outliers are using the fences. Your formula for the fences are quartile 1 minus 1.5 times IQR. I can't write. And quartile 3 plus 1.5 times IQR. You will either have 2 outliers, which are 14 and 16, 3 outliers, which are 5, 14, and 16, 1 outlier of 16, or no outliers. Okay. Here is question number 1 in the second half of the lesson. Use the data Kayla and Destry provided about the weather in San Diego to create a 5-number summary of the data, then calculate the range and interquartile range. So first of all, guess what? It's not in order. I'm not going to sit here and make you watch me put it in order. I have screwed this up so much already, I don't even care. Yeah, your steps are to put this in order, find the 5-number summary, and then calculate the range and the interquartile range. The minimum's 50, maximum is 72, median is 62, quartile 1 is 60, quartile 3 is 66. So if this is written in the correct order that we do normally, we have 50, 72, 60, 62, 66. I don't know why they did it stupid like this. To find the range, you just subtract the maximum from the minimum, so the range is 22. To find the interquartile range, you subtract quartile 3 minus quartile 1, which gives us 6. Here's question 2. We have the same numbers. Okay. Use the data Kayla and Destry provided about the weather in San Diego. How does the range compare with the interquartile range? The range is 22, and the interquartile range is 6. Pause it, figure it out, come back. In this example, the range is 22 and shows the high variability in the temperatures. So while they were there was a big swings in temperatures. The range may appear large in this example due to the minimum and maximum values in the data set. So they're saying those might be outliers. The interquartile range, which is the middle 50%, has a relatively small value of 6 and describes the middle 50% of the data. This shows that there's a small variability in the middle data points. For half the days of Kayla and Destry's trip, the temperatures were between 60 and 66 degrees. So most of the time their trip was pretty steady, but there are probably some outliers to have a huge range like this. Here's a check-in. How do you find the interquartile range? Subtract the value of quartile 1 from the value of quartile 3. It's written as Q3 minus Q1 equals IQR. Okay. Here's question number 3. Mrs. Stiltner is comparing the test scores of her classes. Finding and compare the interquartile ranges of the 2 classes. What do they mean? Okay. Pause it, figure it out, come back. So here we have 78. Quartile 3 minus 70 will give us the IQR of 8, and this one has 84 minus 65 which is going to give us the IQR of 19. Okay. What does this mean? It means that there is a higher variability in the scores of period 2. The middle 50% of the students in period 1 had scores that were closer together. So this class was more consistent. Okay. Here's a check-in. What does the interquartile range show? The interquartile range shows the variability of the middle 50% of the data. If the interquartile range is small, then the middle 50% of the data points are closer together. If the interquartile range is large, then the middle 50% of the data points are more spread out. Okay. A box and whisker plot describes the number of books read by students in 2 different schools. Determine whether each statement is true or false. The students in Class B have a smaller variability in the number of books they read. This is using the same number line for both of these, so this is a true statement. Class B has a smaller interquartile range. That's the space within the box. That is also a true statement. Class A has a larger range. That goes from 0 to 28. That is also a true statement. Class B has a larger maximum. Their maximum is 18. Their maximum is 20. That is a false statement. Here's question number 1. This is all you. Use the data set to answer the question. If a data point of 23 was added to the data, would it have a small or large effect on the interquartile range? Pause it, figure it out, come back. Adding a point of 23 would have a small effect on the interquartile range because the IQR describes the middle 50% of the data. It's that box on the box and whiskers plot, okay? And if you add 23, 23 is going to be an outlier up here, okay? Adding a new maximum value would have a large impact on the range, however, as that changes the maximum. So the original maximum value was 15, so I was wrong. The outlier would be clear up here at 23, okay? Here is another question, number 1, that's all you. The data set describes the number of pets each family in Ingrid's class has. What does the interquartile range suggest? So first you need to find the IQR and then interpret it. Do that, come back. The IQR of this data set is 2, which suggests there is a small variability in the number of pets the middle 50% of families have. Obviously there's an outlier here because you have so many 1s and 2s that we're dealing with. There's probably more than one outlier. The 7 and 10 are probably outliers as well. But the middle set, the middle chunk, the middle 50% is only a variability of 2. So the middle 50% is very consistent. Here is practice question number 4. A meteorologist recorded the following temperatures, which best describes the variability of the temperature. Okay, so it's asking questions about the range, the IQR, and the IQR. So you need to find both of those. Pause it, figure it out, come back. Look, it's not in order because it's stupid. So here's 64, and then 67, and then 69, 67, 69, 71, 74, 71, 74, 78, 81. Let's make sure we got them all because I keep screwing it up. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yay. Okay. So our range in this one would be 81 minus 64, which is going to give us for 17. Okay, that's our range. And our IQR, we need to find our 5-number summary first. So first, let's look at what it says about the range. This is temperatures. It's saying the range is relatively low at 17 degrees range, or the range is relatively high. Okay, well, 17 degrees difference is the difference between needing a coat or a jacket and not needing it. So this one is already eliminated. 17 degrees is a big temperature swing. Okay. Now let's find our 5-number summary. We have 64. We have 81. Let's find our median. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Our median is right there at 71. So we have 67 here, and we have 78 here. So our IQR is 78 minus 67, which is going to give us 9. Okay. So it says the IQR is 11 and the IQR is 17. Did I do this right? I don't trust myself. Let's get my calculator. Let's go 78 minus 67 gives us, it's 11. Well, this one's already out because the IQR is not 17. This one's a possibility. Okay, so we have to pick between these two. The IQR is 11, indicating a fairly high variability for the temperatures for half of the recorded days. 11 degrees is still a big swing in temperature. There's a big difference between 80 degrees and 91, right? The range is relatively high, showing that the temperature will likely be as low as 47 degrees in the next temperature reading. No. There's nothing even close to 47. So this has to be our answer. Here's practice question number 5. A meteorologist recorded the following temperatures. Today's temperature is 67 degrees. If today's temperature is included in the data set, how does it change the interquartile range? These are the same numbers. So we already have our 5-number summary, but we need to add a number into all of this. We're adding 67 in here, so we have two 67s now. So we have 64, 67, 67, what's next? 69, 71, 69, 71, 74, 78, 74, 78, 81. Okay, so we've got our new list of numbers. Pause it, figure it out, come back. Okay, so we got to start with a new 5-number summary. Our minimum is still 64. Our maximum is still 81. Our middle is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. We have to take both of these. The middle between 69 and 71 is 70. So our median is now 70. And then we have to, so this is our dividing line chunk. 1, 2, 3, 4. So right in here, 67 will go here. 1, 2, 3, 4. So between 74 and 78. So we go 74 plus 78 divided by 2 gives us 76. Okay, here's our new 5-number summary. Okay, the interquartile range of the new data set is 76 minus 67. We're getting the calculator because I screwed it up. 76 minus 67 gives us 9. It changed by, what was our IQR before? 11. So it changed by 2. Okay. Now, sometimes this is stupid, so it went down by 2, so it might want a negative. If it's being stupid and it won't take 2, you might have to put negative 2. Here's quick check question number 4. A stock analyst is comparing the interquartile range of the day's stock prices of stock A and stock B. Stock A has an interquartile range of 3 and stock B has an interquartile range of 11. What interpretation can be made from the interquartile range of each stock? Stock B has more variability than stock A. The price of stock B is higher than the price of stock A by 7. The stock price for stock B is higher than the price for stock A. Stock A has more variability than stock B. Go ahead and figure this out. I'll give you a hint. Nowhere in here does it talk about price. Quick check question number 5. A video game player has the following scores. What does the IQR indicate about this data set? So the first thing you need to do is figure out the IQR, which is either going to be 329 or 99.5. Okay. And then you need to determine which of these is the correct explanation. Okay. Skis have scent deals too. And then I wrote this big long about it. Okay, bye.